Hello students, I hope you all are doing good. Let us start with a new session of areas related to circles. Before that, let us see the learning outcomes of this session. Understanding the sector of the circle, understanding of the segment of the circle, application of formulas in word problems. Let us revise a few concepts. This is the sector bounded by the radii of the circle and the portion of the circle with angle theta. This is the sector of the circle. This portion is called the arc of the circle, right? And this portion is called the segment of the circle. Okay? So, let us move forward and see the other concepts. Area of the sector of the circle with angle theta. This is the sector, right? And the angle is theta. Then the area will be given as theta divided by 360 into pi r square. Now, let us see what is the area of the minor segment APB. Let us see in this figure APB. This is the minor segment. Then the area will be sector area AOPB. This is the sector. Subtracting the area of the triangle AOB from the area of the sector, we have the area of the minor segment. Similarly, the area of the major segment. This is the major segment AQB. Then the area will be pi r square, the area of the complete circle minus the area of this minor segment, right? The minor segment area subtracted from the complete circle. So, let us move forward and solve some examples. A horse is tied to a peg at one corner of the square shaped grass field of side 15 meters by means of a 5-meter long rope. Let us see the figure. There the figure is. Find the first part, the area of that part of the field in which the horse can graze, and second part, the increase in the grazing area if the rope were 10-meter long thread of 5 meter instead of 5 meter. The pi value is given as 3.14. Let us move forward. This is the figure and here this is the rope, right, and this is the area grazed by the horse. Let us see, if this is a square, then what is this angle? This angle is 90 degree, right. So, length of the side of the square grass field is 15 meters as given in the question, and length of the rope is 5 meter. So, this is 5 meter, okay, to which the horse is tied to peg at one corner of the field. The first thing we have to find is area of the field the horse can graze. It is clear this is a sector of the circle, this is a sector of the circle, right, wherein theta is 90 degree, theta is 90 degree and length of the rope is 5 meter. So, area of the horse can graze is the area of this sector, and the formula is theta by 360 into pi r square. Let us substitute the value. Theta is 90 degree, r square, then we have pi r square by 4. Let us substitute the value of pi as well as r. We have 25 into 3.14 as pi divided by 4. Calculating the whole thing, simplifying it. So, area of the field the horse can graze is 19.625 meters square. Now, let us see the second part. Length of the side of the square is again 15 meters and length of the rope is 5 meters. Now, the length of the rope is increased to 10 meters. The horse can graze the radius as 10 meters with the angle of measure 90 degree. Now, the length is 10 meters and theta is 90 degree. Now, the area the horse can graze will be area of the sector wherein theta is 90 degree and r, the radius will be 10 meters. Substituting the values in the formula, we have theta by 360 into pi r1 square. Let us keep r1 square as it is. We will substitute the value of r1 later. So, length of the side of the square is 5, increase will be pi r1 square by 4 minus pi r square by 4. Taking pi by 4 as common, we have r1 square minus r square. Here you can substitute the value of r1 square as well as r square. r1 is 10 and r is 5, whereas the value of pi is 3.14. Simplifying the whole thing, we have 58.875 meters square. I hope this question is clear. So, let us move forward. An umbrella has 8 ribs which are equally spaced. Assuming umbrella to be a flat circle of radius 45 centimeter, find the area the 2 consecutive ribs of the umbrella. Since there are 8 equal spaced ribs, these are the ribs. We have 1, 2, 3, 4, 5, 6, 7 and 8. We have equal spaced rib in the umbrella, and this is a, let us assume this as to be a flat circle. The angle between the 2 consecutive ribs will be 360 divided by 8. That comes out to be 45 degree. So, area of these ribs will be theta by 360 degree into pi r square. Substituting the value of theta as 45 degree, we have pi r square divided by 8. Now, we know that the radius is 45 centimeter. So, substituting the value of r as 45 and calculating it further, we have the area between the 2 consecutive ribs as 795.535 centimeter square. I hope this question is clear. So, let us move forward. A car has 2 wipers which do not overlap. Each wiper has a blade of length 25 centimeter sweeping through an angle of 115 degree. Find the total area cleaned at each sweep of the blades. Let us see the figure. This is the area covered by the blades and the angle is 115 degree. This is the radius and the radius is taken as 25 centimeter. So, area cleaned at the sweep of the blades of each wipes will be area of the sector of the angle 115 degree at the center and radius as 25 centimeter. We know that in a car we have 2 wipers. We have 2 wipers of same length and same angle. So, no area is overlapped by the wipers, right? No area is overlapped. So, total area cleaned will be twice the area cleaned at the sweep of each wiper. So, let us see how. Area cleaned will be area of the sector of the circle with radius 25 centimeter and theta as 115 degree. We know the formula as theta by 360 degree multiplied by pi r square. Substituting the value of theta as 115, we have r as 25 into 25. The value will be 23 by 72 into 625 pi. We know that there are 2 identical wipers. So, the total area will be 2 into 23 by 72 into 625 into pi. Now, let us substitute the value of pi as 22 divided by 7. Calculating it further, what we have is 158,125 divided by 126 centimeters square. Converting it into decimals, we have 1254.96 centimeters square. So, the total area swept by both the blades will be 1254.96 centimeters square. I hope this is clear. Let us move forward to our next question. A round table cover has 6 equal designs as shown in the figure. You can see the figure. If the radius of the cover is 28 centimeter, find the cost of making the designs at the rate of rupees 0.35 per centimeter square. We are given that root 3 to be 1.7. A round table has 6 equal designs. These are 6 equal designs. 1, 2, 3, 4, 5 and 6, and the radius of the whole cover is 28 centimeter. Also we are given that rate of making is 0.35 per centimeter square. In the circle we have the radius as r and let the angle be theta. Then the area of the sector will be given by theta by 360 into pi r square. Also the area of the segment will be given by area of the sector minus area of the corresponding triangle. So moving forward, let us see the diagram there. The designs of the table cover are segments of the circle. This is the segment of the circle. See, all the designs are on the segment of the circle, right. So area of the design will be area of the 6 segments of the circle. Since the table cover has 6 equal designs, therefore each of this segment will make an angle of 60 degree. How come 60 degree? We have the total angle as 360 degree and we have 6 equal parts. So we have 60 degree, right. Now consider the segment APB. This is the segment APB, right. This angle subtends an angle of 60 degree at the center. So area of the segment APB will be area of OAPB sector minus area of the triangle. This is the triangle AOB minus this triangle. So let us move forward and see what is the area. We need to find the area of the triangle. This is the triangle AOB. First of all, we need to find the area of this triangle. In this triangle, we already know that AO is equal to OB. Why? These are the two radii of the circle. Also, angle OAB is equal to angle OBA. Why? Angles opposite to the equal sides of the triangle are always equal. So, angle AOB plus angle OAB plus angle OBA is 180 degree. Again why? Because sum of all the 3 angles of a triangle are 180 degree. So, we also know that OAB is equal to OBA. Substituting this, we have angle AOB is equal to twice of OAB is equal to 180 degree. Taking OAB to the left side and substituting the value of angle AOB as 60 degree, we have twice of angle OAB as 120 degree. So, angle OAB will be 120 divided by 2, that is 60 degree. Since all the angles of the triangle are of the measure 60 degree, therefore triangle OAB will be an equilateral triangle. So, area of triangle OAB will be root 3 by 4 side square. This is the formula for area of equilateral triangle. Substituting the value of side, that is 28 centimeter, we have root 3 into 7 into 28. Calculating it further, we have 333.2 centimeter square as area of triangle AOB. So, let us move forward. Area of sector OAPB, this is the sector OABP, this is the sector. So, area of the sector will be theta by 360 into pi r square. And what is theta? Theta is 60 degree. Substituting the value of pi as 22 by 7 and r as 28 and solving it further, we have 1232 divided by 3 centimeter square. Now, what is this? This is the area of the sector. Now, we have to find the area of the segment APB. This will be area of the sector minus area of the triangle. So, 1232 divided by 3 minus 333.2 whole centimeter square. So, solving it further, we know that we have 6 equal segments. So, multiplying this the whole thing by 6 and solving it further, we have 464.8 centimeter square. This is the area of all the designs on the table. So, cost of making 1 centimeter square as in the question is given as rupees 0.35. So, cost of making 464.8 centimeter square, we have to multiply 0.35 by this, and calculating it further, we have the cost as 162.68 rupees. So, I hope this is clear. Let us move forward. A brooch is made with silver wire in the form of a circle with diameter 35 millimeter. The wire is also used in making 5 diameters which divide the circle into 10 equal sectors as shown in the figure. Find the first part is the total length of the silver wire required and the area of each sector of the brooch. You can see the brooch here. These are the diameters wherein the silver wire is used. Also, the silver wire is used in the outer. So, the total length of the silver wire required will be, since the silver wire is used in making 5 diameters and the circumference of the circular brooch. Total length will be circumference plus 5 into the diameter. Now, what is the circumference? Circumference is pi d and 5d is the diameter, 5 into the diameter d. Taking d as common, we have d into pi plus 5. What is this? This is the total length of the silver wire. Now, the diameter is given as 35 millimeter. It is given in the question. So, total length will be pi d plus 5d, substituting the value of d as 35 and solving it further, we have 285 millimeter. What is this? 285 millimeter is the total length of the silver wire required. So, let us move forward. Area of each sector of the brooch. To find the area of the brooch, we have to find the angle made by each sector at the center. This is the angle, right? And we know that the brooch has been divided into 10 parts, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. The brooch has been divided into 10 equal parts. What is the total angle of the circle? It is 360 degree and there are 10 equal parts. So, each angle will be 360 divided by 10, that is 36 degree, and radius of the brooch will be half of the diameter. The diameter is given as 35 millimeter. So, radius will be 17.5 millimeter. Now, area of each sector will be, we know the formula is theta divided by 360 into pi r square, substituting the value of theta as 36, pi as pi r square, again pi as 22 by 7 and radius as 17.5. Calculating the whole thing, we have 96.25 millimeter square as the area of each sector. I hope this question is clear. So, now let us summarize the whole lesson. Area of the sector of angle theta. This is the sector, right? This whole is the sector and this angle is theta. Then the area is given as theta by 360 into pi r square, where r is the radius of the circle. Also, we have studied about the area of the minor segment APB, which is given as area of the sector minus the corresponding triangle. Area of the major segment will be area of the complete circle minus the area of the minor segment. Also, we have studied about the application of all these formulas on a real life problems. I hope all the concepts are clear. Please take care. Thank you.